All right. This lesson is we're going on to similar thing. Last week I went through, or the last lesson I went through compound interest, and we learned how to do compound interest in a long method. So on your calculator, you would have entered one after the other from entry line to entry line. And I said that in the next exercise, you're going to learn a rule for it, even though I already gave you the rule for it. Today, I'm actually just going to show you what they've given you as a rule, and I'm going to show you how to apply it and when to know when it's appreciating or depreciating. But that's what I'm going to be using as part of as I'm calculating through these questions, you'll be using that rule. Now remember, there is a difference between the two types of interest that we had. We had simple interest, which is what we call an arithmetic sequence. It's one where you add or subtract, whilst geometric sequence is when you're multiplying. So you find that in these rules, the difference between simple rule, so recurrence relation, they would have had V naught plus D in the simple interest one. So in the first few exercises of chapter 8, 8b and 8c, that's what you were doing, adding. But you find that now, where we're working on 8e and 8f, it is a geometric sequence, which means you're multiplying. Okay, so that's where the rules go differently. So you either have repeated addition or you have repeated multiplication. And we know from year 7, when you do repeated multiplication, you get indices. So 2 times 2 times 2 times 2 times 2, you'd write it as 2 to the power 5. That's why the compound interest rule has a power of n. That's where it's coming from. Okay, so what you see here are two different rules, but really it's the one and same rule. The only difference between them is, are you adding on the interest rate or are you subtracting a particular rate? Okay, so in this case here, when would you add? It's investments. You put your money into a bank and you want to see it grow, or you put your money, you invest into a share and you want to see some sort of return. So you put in $10, you hope to get more than $10 back after a certain duration. Okay, so it would obviously then be plus. Why is it 1? 1 is what you put in. It's your 100% of what you put in. 100% means 100 over 100, hence why it's 1, plus the percentage of what you want extra. So if I told you that if you give me your money right now, you give me 10, whatever money you give me, the amount of money you give me, I will give you 10% extra every day. Okay, so what you're getting is the amount you get plus an extra 10%. That's what they're trying to say here. The full amount of 1 plus the rate that you get, compounded, which is to the power of n, repeatedly. Okay? What you see in this, the depreciation, when is a depreciation formula available? When you're doing your taxes, which at some point you will. When you do your taxes, they'll ask, you can claim tax back on things like, I bought a laptop. Every year it depreciates in a certain value. If I say that I'm using this for work purposes, I spent money, I forked out, they'll say, all right, cool, we'll take off a certain percentage, and they tell you how much you can take off every year. Okay, so because I'm taking off, I may have bought this, say, $2,500, then how much of a percent am I losing every year? So they may say in the first year, you lose, the value goes down by 3%, so then 1 is 100% of the laptop, so $2,500, minus the 3% of whatever the cost or the price of the laptop was. That's why it's minus, because it's depreciating value. So the more times you compound it over time, it should decrease in value rather than increase. And that's why we call it depreciation versus interest loans and investments. But really, it's the same formula. Both of them are exactly the same. The only difference between them is whether you subtract or add. Your goal is when you read the questions, you determine, is it appreciating or is it depreciating? Okay, and then that's the difference between the two. But really, the two rules that we've learnt so far is either a geometric sequence or an arithmetic sequence. You either grow or you lose in both scenarios. Okay? So let's do an example here. As you're copying this down, this is the rule that I would like you to copy down. Vn represents the value after X amount of compounding. Okay, so n amount of compounding. So if you compounded 2 times, then what is the value? The value is equal to V naught, which means the amount you started off with, multiplied to the rate added on, okay, or the rate subtracted from your original To the power of n means how many times you're going to compound that. This is a geometric sequence, hence it's to the power of n, right? So, let's do an example together. I already did this one over here. Have a look at my calculations and how I use the rule, but I'm going to do an example just below with you right now, just so that you can see how I use these two rules and really only use the one rule to answer this question. Okay, so here we go. Let's have a look. Example 20. It says, calculating the value and total depreciation of an asset after reducing balance depreciation. Big words. Let's just find out what they're trying to say. They tell you that a computer system costs $9,500 to buy. So that's obviously the amount that I'm forking out right now. And it decreases in value with reducing balance depreciation of 20% each year. See, I don't really mind what the other words are. All I care about is what's happening, what's the rate. I'm depreciating, and it's 20% each year. So that's my rate, okay? A recurrence relation, so here they try to give you the rule. In fact, they've given you the rule already. To understand this concept a bit more, I'm gonna show you exactly where it starts from. So you start off with $9,500, that's how much you bought the computer system. The rule that we saw before was the compound interest formula, which was Vn is equal to, in this case, V naught, which is what you start off with, multiplied to 100% of itself. And in this case, we're not adding on, we're depreciating. So we're losing over time. So it should be subtraction of the rate, which is in percent. That's why it's over 100. So percent. So if it's 2%, it's 2 over 100. If it's, in our case, it's 20%, it's 20 over 100 to the power of n. N is the number of times you're going to compound that. Okay, so if it compounds every year, which is what it says here, depreciation of 20% each year, that means every year. N equals 1 means after 1 year. N equals 2 means after 2 years. Okay, this is the amount that I'll be losing over time, depreciating from my initial value. Okay, so let's put it all together. Let's see how they got 0.8 times Vn, because they really got it just from this idea here. So I'm going to apply it. I'm going to say, all right, well, V naught I start off with $9,500. I'm multiplying that to 1 minus 20%, which is 20 over 100, to the power of n. On your calculator, you can actually find out what 20 divided by 100 is, which I know is 0.2. And that's why they had 1 minus 0.2. That's where your 0.8 came from. Okay, and this tells you Vn. That's essentially what they're saying here. So what I've just got here, which is based on the rule that I told you to copy down just now, starting off with that rule, that's what they're saying up here. That's all they're saying. They're saying Vn times 0.8. I do have Vn times 0.8. That Vn is my V naught, 9,500. That's where it is. That's the rule. If I want to find after 1 year, after 2 years, that's what n is going to replicate. So, to answer the first question, that was A. B was use the rule to find the value of the computer system. So I want to find the value of the computer system after 8 years. So if I know it's compounded every year, write your answer correct to the nearest cent. Here we go. I would then say, well, I want after n equals 8 years, so if there's 8 years, that means it's going to compound 8 times. So I know n has to be 8. So here, what's my value? V of 8 must equal to your initial value. You start off with 9,500 for the system. How much does it depreciate after 8 years? Well, 0.8 to the power of 8 is what I'm doing. That's the quick way of doing it. Instead of doing entry line per line like you did in the last exercise, this should be the faster way to do it. So I'm now going to type it on my calculator. Here we go. I'm just going to delete the last one I did. Clear history. Here we go. 9,500 times. Actually, I should do the old method as well. If you were to do the old method, this is how you would have done it. You would have said times 0.8, press enter, and you keep pressing enter until you reach the 8th term. So this is what you did last exercise, right? So this is first year, second year, third year, 4th year, 5th year, 6th year, 7th year, 8th year. So I know the answer is the value should have depreciated from $9,500 down to $1,593 after 8 years. But that was a while to do. If I told you to do 88 times, you don't want to be sitting there pressing 88 entries. So there must be a faster way. And what we just calculated here should be faster. So let's see if the answer comes out to be the same. If I did 9,500 times 0.8 to the power of 8, see how they both come out the exact same? So that teaches you that in this exercise, you don't have to do entry by entry each time to get to the 8th year. You can actually calculate the 8th year from that. That means if I want to find the 88th year, it's still easy. I can just go back, highlight it, press enter, and I change the power to 88. That's how small it's gone down to technically 0, really. Okay, so $0 after 88 years. Okay, so you can do it with a formula, and that's what these questions are doing. They're just getting you to use the formula, but determine, is it appreciating or is it depreciating? There's only technically one formula. Okay, so here we go. I've answered my question here. The value now becomes to nearest cent, which I'll just copy paste this section, $1,593. Just paste that right here. So it was 1,500. I should just do it here. There we go. $1,593 point to the nearest cent and 84 cents. Okay, so that's B. Part C says calculate the total depreciation of the computer after 8 years. So be careful when you're reading these questions. It matters what you're looking for. Are you looking for the interest? Are you looking for the value? In this case, when they say total depreciation, what does that mean? What are they asking? The amount that it decreased by. Okay, so after 8 years, I know what the value is, but how much did I lose? I started off with $9,500 and then I ended up at $1,593. I want to know how much I've lost. That's what they mean by total depreciation. So to find out total depreciation, well, I know it must be, I start off with $9,500 and I ended up at 1,593.83. And keep in mind as well, don't make the mistake of using your rounded answer. Okay, use your total answer and then you round your final answer, because if you keep rounding in each calculation, you lose cents as you go. So you should be using the total value. So it should be 9,500 minus whatever you had before, not the rounded answer. So if I go with that, here we go to our calculator, 9,500 minus, and I'll go back and highlight, that's the value. That's my actual value there. So I'm just gonna put it, copy paste this section. Can I enter it down? There we go. So answer must be $7,906. And if you want to round this one now, that's okay. Okay, so that tells me the difference. That's how much I've lost, and that's what they mean by total depreciation. Okay, so read the question. Some of it may ask how much interest that you had within that year. That's what you're calculating. Okay, but really, this is all you needed to know. It was just that formula that I want you to get familiar with. Addition is you're growing, minus means that you're losing, and that's what these questions are simply asking for. Okay, so I'm going to give you a bit of time now to have a go with that formula. Let me know if you're sort of getting a bit confused of what the questions are asking, but that's what I want you to practice there. So understanding geometric sequence versus arithmetic sequence, they are different. Knowing when to use them, is it an appreciation or is it a depreciation, is what you're trying to figure out. Okay, going to give you that time.